objective of the assignment is to equip students with the skill necessary to analyze and simulate a broad range of real-world issues by studying vector calculus, differentiation, and integration. In many scientific and technical applications, these mathematical methods are crucial for comprehending and elucidating the behavior of functions.
Assalamualaikum to everyone. We are from Group 6. We want to present our group project, which is a calculation of differential and integrate and vector. Question 1 given r equals to 90 minus t cubed. So to find the rate of change in radius, we must to differentiate first. For a, t equals to 2. So we substitute 2 into the differentiate and we got -3, which is increase. And for the b, t equals to 1. So we substitute 1 into the differentiate and we got 6, which is radius is increase. And for c, t equals to 2.5. So we substitute 2.5 into the differentiate equation, we get 2.25, which is radius is increased. For question 2, 2a, what is the initial radius of sphere? So t equals to 0. We substitute t into the r equation, which is 3 plus 1 over 1 plus t, and we got 4. Thus the initial radius of the sphere is 4 cm. For question 2b, determine the rate of change in the radius when t equals to 2. So first we must to differentiate equation of r, which we got negative 1 over bracket 1 plus t square. Then we substitute t. For question 3, determine the rate of change of the area when t equals to 1. So first of all, we must differentiate r, and we got 4t. Second, we differentiate a, which is we got 2 pi r. And by using chain rule, we got the equation dA over dt equals to dA over dr times dr over dt. And we got the equation which is 2 pi r bracket 4t. Then we substitute t equals to 1 into the equation, and we got dA over dt equals to 8 pi r. For question 4a, how are dA over dt and dx over dt related? So we know that area of square is x squared. So we differentiate dA over dt, we get 2x. And we use equation dx over dt equals to dx over dA times dA over dt. We know that dA over dx is 2x. So we substitute it in the equation, we get dx over dt equals to bracket 1 over 2x times dA over dt. For 4b, we know that x equals to 3 and dx over dt equals to 2. So we use the first equation at 4a and substitute 2 into dx over dt and x into x, and we got dA over dt equals to 12.
For the question 5a, they ask us how the dAdt and dxdt relate. So we differentiate both sides as respect to t. We just need to do the product rule on the right side, then we got the equation. For the question b, we already got the equation and all the values, so we have just substitute it on the equation. And we got the answer. There is decreasing at rate 25 cm per second. For the question C, we rearranging the equation and refactoring the quadratic equation. Then we got the intersection point of x, which is x equal to 2 and x equal to 6. Then we do the integration of the equation and split based on the range of x values. We evaluate the equation and got 32 over 3 for the area. And the last question for this topic, which is question 7, we just rearranging the equation and substitute the value of y and gets x equal to 2 and x equal to 0. Then we sketch the graph and got as shown in the answer. After do the graph, we integrate the equation and split based on the range of x values and got the answer is 2. For the question 1, vector they give us the point of intersection. So we just sketch our graph using the point that was given.
For question 2, equation 2a, bracket f plus g bracket T. This question, we need to find F plus G, and this implies and the corresponding component of F and G together like this. And we explain that that's for question to be bracket F multiply G bracket T. This question same like 2A, where we need to apply at the corresponding component of F and G, then we use the cross product formula to find the answer. Okay, for question 2C, bracket F dot G bracket T. For this question, we need to find corresponding of F and G. We need to use the dot product of F and G, and we have the answer for the next question. For 2D, F bracket T dot bracket F multiply G bracket T. From this question, we know we have to, for question 2B, that same answer, because this part we can take the answer for question 2B and we conclude for question 2D. For question 2D, we input the ft dot bracket f multiply g bracket t, and the answer we get. Okay, for question 3, for question 3A, this question we need to differentiate for I, J, K for each side. I will show you that this I will differentiate the each side, and the differentiate we got. Then the question also say that we need to differentiate again, and we use the first differentiate. Then we got next for question 3B. This is also same like question 3B. Differentiate I, J, K, and next we need to differentiate second derivative for arc theta. And for question 4, question 4A, we need to find the derivative of RT. We conclude the equation for A, for equation R, and we differentiate. We got, and set 2, we need to substitute T equal 1 into first derivative of R to find the derivative of the given point. And we got the answer that we must normalize with first derivative. Then we conclude 1 to find T bracket T. Then we get the answer. Let's find the principal unit normal vector and T using the cross product. We use the principal unit formula, and using the right hand rule, we can determine that K multiply I equal to J, and K multiply J I, we got I. Then answer we get for question for B. First step, we do same with question A and find the derivative, first derivative of R, and we substitute first derivative. We conclude that next we normalize first derivative, then we conclude the answer. Okay, for step, find the principal unit normal vector and T equal K multiply T, then T is formula, same like question A, and the answer we got. Okay, move to question 5. For question 5, find the curvature of the following weights. For question 5A, first thing first, we need to differentiate to get velocity vector, and we got the answer. Then we do second derivative to get acceleration vector by taking the derivative of Pt with respect t, and the magnitude of the velocity vector Pt, we got of the acceleration vector AT, we got also same like velocity vector, which is E2. And we do the curvature KT using the formula. This is the formula, and we substitution the value, then we get 1. Question 5B, the question given T equal to Ti plus T square J plus 1 over 3 T cube K. First, we do same like question 5A, do differentiate. First differentiate to get velocity vector by taking the derivative of RT with respect to T. And the answer at T equal dV over dt equal 2J plus 2K. Then we find the magnitude of the velocity vector Vt. We got use like this on 2 square plus bracket 2t square plus bracket 2 bracket t square square. And we find the curvature TAT using the formula like I showed for you. And we substitute the value that we got.
Assalamualaikum. My name is Muhammad Yunus bin Abdullah. I continue the vector for question number 6, A and B. Both questions are using same method, which are we need to find first, second, and third derivative for this question. After differentiates, we substitute t is equal to 1 over 2 pi, and also t is equal to 1 for question B. After get the value, to find curvature, which is k, we need to find by using the cross product and magnitude. After we get the k, we can calculate the radius of curvature, which is r is equal to 1 over k. So question number 7. By following the question, first we need to find the unit tangent vector. From that, we need to normalize differentiation by dividing it by its magnitude. After we get first derivative and magnitude, we can get the unit tangent of vector. Second, to find the principal unit normal vector, we need to differentiate the unit tangent vector with the respect of t and normalize it by the resulting vector. After we get the answer for both vectors, we can find the binomial vector for both vector by making the cross product of unit tangent vector multiplied by principal unit normal vector. And lastly, we must find the curvature at t is equal to pi and substitute in three type of vector. Number 8, we need to integrate each component separately by using all the type of integration that what had learned in the class and solve it correctly. And last, putting all components together. For question number 9, we need to integrate each component separately by applying the basic integration and calculate each integration, and then putting all components together in vector functions.
For question 10a, to get the velocity, we will differentiate RT, and the answer we will be getting is negative 2 sin Ti, 2 cos Tj, and 1k. Then to get the acceleration, we will differentiate Vt, and the answer will be negative 2 cos Ti, negative 2 sin Tj, and 0k. Next, to find speed, we need to substitute the value t equal to pi over 4. Then the equation will be set negative 2 sin pi over 4 square plus 2 cos pi over 4 square plus 1 square. After we simplify, we will get the final answer of speed, which is set 5. For the direction, we need to substitute value of t equal to pi over 4. We need to apply the formula velocity over direction to obtain the direction of motion. So the final answer will be negative 2 over set 10 I, 2 over set 10 j, and 1 over set 5. For b, to get the velocity, we will differentiate RT, and the answer we will be getting is 2i, 3 over tj, and 2 e to the power of 2 tk. Then to get the acceleration, we will differentiate Vt, and the answer will be 0i, negative 3 over t square j, and 4 e to the power of 2 tk. Next, to find speed, we need to substitute the value t equal to 1. Then the equation will be set 2 square plus 3 square plus 2e square. After we simplify, we will get the final answer of speed, which is set 13 plus 4e to the power of 4. For the direction, we need to substitute value of t equal 1. We need to apply the formula velocity over speed to obtain the direction of motion. So the final answer will be 2i 3j 2e square k over set 13 plus 4e to the power of 4. For question 11a, to find the position vector from the velocity given, we will integrate Vt and the answer will be tq over 3 plus c1 e to the power of 2t over 2 plus c2 t square over 2 plus c3. After that, we need to compare the new value of r0 and the given value of r0. The final answer will be tq over 3 plus 1 e to the power of 2t over 2 plus 3 over 2 t square over 2 plus 1. For b, we will integrate Vt and the answer will be 4 over 3 to t to the power of 3 over 2 plus c1 sin t plus c2. After that, we need to compare the new value of r0 and the given value of r0. The final answer will be 4 over 3t to the power of 3 over 2 plus 1 sin t plus 2. For question 12, to find the particle position, we will integrate Vt and the answer will be e to the power of t plus c1 2t square plus c2 negative 1 over pi cos pi t plus c3. After that, we need to compare the new value of r0 and the given value of r0. The final answer will be e to the power of t plus 1 2t square negative 1 negative 1 over pi cos pi t plus 2 over pi. For question 13, the question asks us to find RT. First, we will integrate AT and the answer will be sin 2t over 2 plus c1 negative 4t plus c2 e to the power of 2t over 2 plus c3. After that, we need to compare the new value of v0 and the given value of v0. The answer will be sin 2t over 2 negative 4t e to the power of 2t over 2 minus 1 over 2. Next, we will integrate Vt and the answer will be negative cos 2t over 4 plus c3 negative 2t square plus c4 e to the power of 2t over 4 plus c5. After that, we need to compare the new value of r0 and the given value of r0. The answer will be negative cos 2t over 4 plus 1 over 2 negative 2t square plus 1 over 2 e to the power of 2t over 4 plus 1 over 2.